All right, get ready, because today we're going deep into the world of energy.
Energy.
But not the kind that keeps your lights on.
Right.
We're talking about energy that makes things move.
Yeah, it's fascinating how much we just take movement for granted.
I know, right?
Like there's so much physics happening.
Yeah.
Even when you just lift your hand.
To help us out, we've got this amazing resource.
Okay.
It's about projectile motion and energy conversion.
Oh.
It's designed for students, but it's got some really interesting points for everyone, I think.
Definitely. The core idea is that energy is what makes things move and work.
And we've got some fun stuff to talk about, too,
Yeah.
like bouncing footballs, interactive simulations,
Yes.
even building our own energy model.
So before we get into projectile motion,
Go ahead.
let's lay some groundwork.
Okay.
We're focusing on kinetic energy today.
Okay.
That's the energy of motion.
Right.
And potential energy. Energy waiting to be unleashed.
Okay, so I'm thinking of a roller coaster
Okay.
at the top of the hill.
Yes.
That's all potential energy,
Right.
like a coiled string
Exactly.
ready to explode.
And as it goes down the hill,
Yeah.
that potential energy turns into kinetic energy.
So it's like a dance
Yeah.
between those two.
A constant dance. Yeah.
Our source mentions this really cool interactive simulation.
Okay.
With a football,
Uh-huh.
you can drop it,
Yeah.
toss it upwards,
Yeah.
even throw it horizontally.
And the cool thing is it lets us plot energy graphs
Oh, wow.
over time.
Okay.
So we can see how those different energies change.
So let's try one of the sample questions
Okay.
from the source.
All right.
Imagine we drop the football straight down.
Okay.
What happens to its kinetic and potential energy
Okay.
as it falls?
So as it falls, it loses height,
Right.
which means it loses potential energy,
Okay.
like walking down the stairs.
Right?
But it's also gaining speed.
Yeah.
So it's gaining kinetic energy.
So it's like a trade-off.
Yeah.
One goes down, the other goes up.
Exactly.
And that's why something falling gets more dangerous as it falls.
Exactly. The longer it falls, the faster it gets.
Right, because of the kinetic energy.
Exactly.
Okay, so what happens if you toss the ball upwards instead of dropping it?
Okay, so picture it going up.
Yeah.
It slows down as it goes up. Like
Yeah.
it's fighting gravity.
Yeah.
So its kinetic energy decreases as the ball slows down.
Oh, wait.
And its potential energy increases as it gains height.
Right.
But at the very peak,
Yeah.
everything flips. For a split second, it just hangs there.
Right.
And then gravity wins and it falls back down.
So what about the total energy during all of this?
That is the question.
Does it change?
That's going to unlock some really cool physics for you.
Okay, I'm ready.
So in a perfect system
Okay.
where there's no air resistance,
Okay.
the total energy stays the same.
Wow.
It doesn't matter if it's falling, rising, or at its peak, the total energy is always the same.
That's incredible.
Isn't that neat?
So energy isn't just appearing and disappearing.
Right.
It's just changing form.
Yeah, like a master of disguise.
But the total amount is always the same.
Exactly.
Now, our source challenges us
Okay.
to build an equation that models kinetic energy based on speed.
Ooh, fun.
And to give us a table of data to play with.
I love a good data table.
But before we get into that, can we talk about that free fall and rebounce setting?
Yes.
In the simulation?
Yeah.
In the real world?
Yeah.
The ball doesn't bounce back to the same height every time.
Right.
It's like some energy disappears.
It seems like it vanishes.
Yeah.
Right.
Is that what our source is talking about?
You're on the right track.
Okay.
When we bring in the real world, things get more complex. We'll
Right.
get into that after we look at this equation.
Okay.
Because it helps to understand the ideal version first
Okay.
before we add the complexity.
Got it. Okay. So let's look at this data table.
Yeah, it's like a puzzle
Yeah.
waiting to be solved.
It's got different speeds for the football.
Right.
And the corresponding kinetic energy values.
Uh-huh.
I'm excited to see what we find.
Me too.
As the speed increases,
Okay.
the kinetic energy also increases.
Yes.
But not at the same rate.
Right. It's like the kinetic energy is accelerating faster
Yeah.
than the speed itself.
So how do we figure out the exact relationship?
Oh, so remember how that second column
Yeah.
showed v squared?
Right.
That's a big clue.
Okay.
It suggests that kinetic energy might be proportional to the square of the speed.
How do we test that?
We got to use our calculators.
Oh, no.
I know.
Math.
Let's look at the ratio
Sure can.
between kinetic energy
Yeah.
and v squared.
Okay.
For each data point,
All right.
if we're right,
Uh-huh.
that ratio should be pretty consistent
Oh.
throughout the table.
So the first row has a speed of 0. So E squared is also 0,
Yes.
and the kinetic energy is 0.
Yeah, there's not much to work with there.
Yeah. Okay.
Let's move to the second row.
Okay.
The speed is 1 meter per second.
Okay.
So V squared is 1,
Uh-huh.
and the kinetic energy is 0.5 joules.
Okay.
The ratio between kinetic energy and V squared is 0.5.
Okay. The next row,
Yes.
the speed is 2.
Okay.
E squared is 4.
Uh-huh.
And the kinetic energy is 2 joules.
All right.
So the ratio is 0.5 again? Is that a coincidence?
We need more data points
Oh,
to be sure.
I've done the calculations.
Okay, tell me what you see.
It's 0.5 every time.
Wow.
So cool.
That's awesome.
It's like we cracked the code.
We did.
So kinetic energy is proportional
Yes.
to the square of the speed.
Precisely.
So if we write that as an equation,
Okay.
would it be kinetic energy
Yeah.
equals some constant
Yes.
times v squared?
You got it.
And that constant is 0.5.
Yes. But there's one more piece of the puzzle.
What's that?
Our source mentions
Okay.
that the mass of the football
Okay.
is 1 kilogram.
So the mass of the object matters.
Yes.
So a heavier object
Yeah.
moving at the same speed as a lighter object
Mm-hmm.
would have more kinetic energy.
Exactly.
So the full equation
Yeah.
needs to include the mass.
Yeah, right?
So it's K equals 1/2
Yes.
times the mass and
Yep.
times z squared.
That's it.
That makes a lot of sense.
It does.
A heavy truck
Yeah.
moving at the same speed as a bicycle
Mm-hmm.
has way more kinetic energy. That's why
Right.
it's so dangerous.
Exactly. That's a great application of this.
So this is like
Yeah.
swinging a baseball bat.
Yeah.
A heavier bat
Right.
would have more kinetic energy.
Right.
So it would hit the ball harder.
Yes. The mass of the bat
Yeah.
combined with how fast you swing it
Yeah.
determines the kinetic energy.
Remember when we were talking about the free fall and rebounds
Yeah.
thing? Where the ball doesn't bounce back to the same height?
Mm-hmm.
Is this a good time to talk about that?
Yes.
Okay.
It highlights the difference between an ideal system,
Right.
where total energy stays constant,
Uh-huh.
and the real world,
Yeah.
where things are messier.
Okay, so what happens to the energy?
So think about the sound
Okay.
when the ball hits the ground,
Right.
or the heat generated.
Oh, yeah.
That's all energy
Okay.
being transformed
Mhm.
into things that our model doesn't account for.
So the total energy is still there.
Yes.
It's just hard to track.
Exactly. It's spreading out like,
Okay.
into different forms.
Okay.
Like sound and heat.
That makes sense.
But the core concept,
Yeah.
energy conservation,
Mhm.
still holds true.
Even something as simple as a bouncing ball.
I know. It's amazing how
Yeah.
much we can learn from it.
So what does this all mean for us?
That's a great question.
How do these ideas play out?
Well, our source emphasizes
Yep.
that energy makes change and movement possible in
Uh-huh.
everyday life.
Yep.
Like think about walking and running,
Okay.
cooking,
Uh-huh.
even typing on a keyboard.
Right.
It all involves energy transformations.
We're like walking energy converters.
We are.
That's so cool.
Yeah.
But our source also says
Okay.
energy is required to enable things to work or move.
Yes.
It seems obvious,
Right.
but is there more to that?
It makes us think about where the energy comes from.
Oh, okay.
And the costs,
Right.
the electricity that powers our homes,
Yeah.
comes from different sources,
Right.
each with its own environmental impact.
Like we just flip a light switch
Yeah.
without even thinking about it.
Right. But there's so much happening behind the scenes.
Yeah.
Power plants, transmission lines.
To get it to our houses.
Exactly.
So we've talked about how energy powers
Yeah.
like the physical world.
Yes.
But what about the energy inside us?
Ooh, good question.
How can we connect these ideas?
Okay, so just like the football. Okay.
We have our own store of energy,
Uh-huh.
physical, mental, and emotional.
And we can transform that energy.
Yes, we can direct it
Okay.
and use it to make change.
So it's not just about the energy that makes things move around us.
Right.
It's about the energy that drives us.
Exactly.
That motivates us.
Yes. The energy that lets us make things happen.
This has been such a cool deep dive.
I agree.
We've gone from bouncing footballs
Yeah.
to our own potential.
So as we wrap up,
Yeah.
we want to leave you with something to think about.
Okay.
If energy is behind all movement and change,
Mm-hmm.
what does that say about our potential?
Ooh.
We all have this energy inside us
Yeah.
waiting to be unleashed.
That's a great point.
Yeah.
Welcome back. So last time we were talking about how energy is like everywhere in everything we do.
It's incredible, right?
Yeah, it really is when you think about it.
Even like really small stuff,
Yeah.
like just picking up a cup of coffee
Okay.
or turning a page in a book.
Right.
It all involves energy changing.
All right.
Okay, so walk me through that.
Okay, so the coffee example.
Yeah.
When you lift the cup,
Yeah.
you're using chemical energy
Okay.
stored in your muscles,
Mm-hmm.
and that comes from the food you eat,
Okay.
right? So as you lift the cup,
Yeah.
that chemical energy
Really?
is turning into kinetic energy,
Right.
the energy of motion.
Okay.
And at the same time,
Yeah.
you're also increasing the cup's potential energy
Okay.
by, like, raising it higher
Oh, I see.
above the ground.
We're like walking energy converters.
We are.
But our source says
Mhm.
energy is required to enable things to work or move.
Yes.
Kind of obvious.
Right.
But is there more to that?
It makes us think about
Okay.
where that energy comes from
Right,
and the
right.
costs.
Yeah, like electricity
Yeah.
that powers our homes.
It comes from lots of different sources.
Yeah.
And they each have their own
Okay.
environmental impact.
Like we just flip a light switch.
Exactly. We never think about
Yeah.
everything that has to happen
To get it there.
to get that electricity to us.
Okay, so we talked about energy in like the physical world.
Mm-hmm.
But what about the energy inside of us?
Okay, so just like the football,
Okay.
we have our own energy.
Oh.
Physical, mental, and emotional.
And we can transform that energy.
Exactly. We can use it
Okay.
to make change.
So it's not just about energy making things move around us.
It's also the energy that drives us.
That motivates us.
Exactly.
That lets us do things.
That's a good way to put it.
This has been such a cool deep dive.
I agree.
We've learned so much about energy.
Yeah.
From bouncing footballs
Uh-huh.
to our own potential.
So as we wrap up, we
Yeah.
want to leave you with this.
Okay.
If energy is what makes everything happen,
Yeah.
what does that say about the potential we all have?
That's an awesome point.
It's really amazing to think about.
Yeah, so next time you're feeling stuck,
Okay.
remember what we talked about today?
Yeah.
Remember the energy inside you
And how you can use it.
to reach your goals.
Exactly.
Thanks for joining us for this deep dive on energy and motion.
We hope you learned a lot.
We'll see you next time.